In this problem, we are asked to find the energy contained in a 120-meter long laser beam. Okay, so how do we find the energy contained in such a length? So let's understand what is going on here. So if you take, let's say this is a laser beam. Okay, so that's the laser beam. Okay, let me get a straight line. Okay, I think that's fine. Okay, so let's take two cross sections. Okay, so this is one cross section, this is another cross section. This is 120 meters long. Okay, now if I consider the photons which are here at this cross section, the left cross section, at time t equal to 0, they are going to reach the other cross section which is 120 meters away at some later point in time, right? At some later moment in time. So how do we find that time? The time is distance by speed. Okay, so distance is 120, speed here we are talking about speed of the photon, so this is a photon by the way. Okay, so we know these photons travel at a very large speed, which is 3 into 10 to the power 8. Okay, so we have the time here. Okay, so what is the time here? I think we can write 4, and then if 10 to the power minus 7 seconds. Okay, so in this time the photons will reach the other cross section. Okay, okay, so they're going to reach here. Now, what happens to the photons that were generated in between? Okay, so the photons, if they were at the left cross section, okay, so here they're going to reach the right cross section at time t equal to 4 into 10 to the power minus 7 seconds. But the photons which were generated before this time, they will all be present in this region, right? So the energy of all those photons is the energy contained in that length. Okay, so that is what they are looking at here. Okay, so all the photons which were generated before, they will be somewhere here. Okay, so the energy of all these photons is what we need. So what we can do, we can just take the power that is given and then multiply by the time. Okay, so that is the energy that was emitted, and then that energy is contained in that region. So simply the energy becomes power times time. Okay, so 4 milliwatt, so 4 into 10 to the power minus 3, and the time is 4 into 10 to the power minus 7. So this would be 16 into 10 to the power minus 10 joules. Okay, so we need to express the answer in terms of some number into 10 to the power minus 10 joules. So the answer will be 16.